Hi guys, today we're gonna learn about sigma. Yeah, Cookie Monster's not gonna teach this. I am, but we are gonna learn about sigma. So we've been doing the sequence and series stuff, right? Which is pretty cool. You know, we found some neat things with series and sequences and all that kind of stuff, and how to write out general terms, and you know, we've done some pretty neat stuff. But I don't know about you, but this whole thing about, you know, Sn equals u1 plus u2 plus dot 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 is kind of annoying, having to write out all those u's, and I don't, this whole dot 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 thing, I don't know how mathematical that really is. So we're going to see if we can kind of do something different with that today. Alright, so what we're going to learn about today is called sigma. Now the sigma is, as many of you have noted, the big E. However, it's not an E, it's actually an S. It's a Greek sigma, which is, it's a capital sigma. A lowercase sigma actually looks like this, and like that. We'll see that a little bit later. That's a lowercase Greek S. But this is a capital S, and it's S because it stands for the sum. That's what sigma is. In mathematics, it stands for a sum. And when we do this, we usually start at some number, and we go up to our last number, and it's of some, it could be of some function, some constant, something else. So u again still represents a term, and so this is saying we start with the first term, so k would be 1, so u1 plus u2, because then we would go up to 2, up to 3, and we go by unit increments until we get up to n. And so we do 1, and then 2, and then 3, and all the way up to n, and because it's summation, we would add them all together. So this right here means exactly the same thing as that right there. Pretty smooth, huh? So what we want to do now is just kind of get used to a little bit of this whole idea of sigma, work through a couple of example problems, and write some sigma notation, and maybe learn a couple of rules. So we'll just kind of see what we can get through in the next couple of minutes. All right? So first, let's just work through a couple of examples. So I got sigma. We're going to go from k equals 1 to 4, and we're going to do this for the function k plus 1. Alright, so what we're going to do, and I'm going to write this out longhand, and you'll learn some other ways to kind of deal with this and work through this, but right now we're just going to write out longhand. So first I'm going to put in 1, so that'll be 1 plus 1, so that's my first term, and then I'll go to the next unit, which would be 2, so I'll put 2 in, so I'll go plus 2 plus 1, so I'm still doing the k plus 1, and then I go plus the next number, which would be 3 plus 1, right? And then I would go 5 plus 1, 4 plus, I was going to say 5 is a joke, and then I said it for real. Anyway, there we go, 4 plus 1. And so we've added up from k equals 1 all the way up to k equals 4, and then you can just add them together. 2 plus 3 plus 4 plus 5, which then gives us 14. And so this right here, sigma from k equals 1 to 4 of k plus 1 is equal to 14. Alright, so try another one. Let's do another one here, and this one I'm going to write down, and then I'm going to say pause so that you can try it on your own. Please do try it on your own, see if you can figure it out. So this time let's start at 2, and you can start at whatever number you want, and we'll go up to 5, and we'll go of 1 over 2 to the k. Alright, so why don't you pause this and try it out for yourself. Pause. Alright, so hopefully you've tried it out, and hopefully you did this. Hopefully you went 1 over 2 to the first k is 2, so 2 to the 2, and then plus 1 over 2 to the 3, plus 1 over 2 to the 4, all the way up to 5, so plus 1 over 2 to the 5th, and then you can put all that together. Alright, so you got 1/4, 1/8, 1/16, and 2 to the 5th, which is 32, so that's 2 32s, that's 4 32s, that's 8 32s, so 12, 13, 14, 15, so that gives us 15 over 32. So there you go, not too bad, right? So now you kind of got an idea of what sigma is. So now what I want to do is kind of introduce to you the idea of now doing a series, okay? So we've got a series, or actually let's just, yeah, we'll go 2 plus 12 plus 22 plus 32, and our super mathematical dot 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 and then all the way up to plus 102. So when we're doing this, the first thing we need to do is figure out what's being added each time, right? So we'll go ahead and we'll say, okay, well, this is obviously 2, and then this one is 2 plus 10, and then this one is 2 plus 20, and then this one is 2 plus 30, all the way up to ... 2 plus 100. So we can do this just by finding the general term, right, and then add them up from 1 to n. So we know that this is a constant difference. Constant difference is 10, so we can say d equals 10, and now we can write out our formula. So we can say un equals u1 plus d times n minus 1, right? And so we now know that un equals 2 plus 10 times n minus 1. And so essentially, we're just going to add all those up from n equals 1 all the way up to whatever one this is. And so if I want to know what that is, well, you can probably count here if you wanted to, but if you want to do it mathematically, you can do that as well. Just put 102 here, and we go 102 equals 2 plus 10 to the n minus 1. We move the 2 over, that makes it 100, divide by the 10, so we get 10 equals n minus 1, and so n is 11. And so we can write our final sigma here, and we just go sigma from k equals 1 to 11, because I've got 11 terms there, the first term, the second term, the third term, all the way up to the 11th term, of 2 plus 10 times n minus 1. And so then we've got a sequence written out right there. So instead of having to write out all this or all that, I now have it simply as sigma there. All right, so I'm going to write another one up here, and I'd like for you to try it. All right, so here we go. Try this one. Let's go -8 plus 4 plus -2, which would be the same thing as -2 plus 1 minus 1/2 ... on as long as we want to go, all the way up to infinity. All right, so go ahead, pause the video and try this one out yourself. Okay, so hopefully you are recognizing that you've got r equal to -1/2, because 4 divided by -8 is -1/2, and -2 divided by 4 is -1/2, and 1 divided by -2 is -1/2. So we've got r equals 1/2. So we can say un then is equal to u1 times r to the n minus 1, which is just your geometric sequence, right? And so now we just need to sum those up. So we do our summation, and we start at k equals 1, and we go all the way up to, we don't stop, we go all the way up to infinity. Oops, go away, there we go, infinity. And then we've got u1, which is -8, and then r, which was -1/2, to the n minus 1. And so, sorry, that would not be n minus 1, that would be k minus 1, and I believe I made that mistake over here as well, sorry. This is not n, it's k, because we are going from k equals 1, and then 2, and then 3, and same thing here, start with k equals 1, and then 2 and 3. There's actually no n in this sigma, because we're not going up to n, we're going up to infinity. So, there you go. You've worked out a couple of examples with sigma, and gotten a little bit of idea of how it works. You'll do a bunch of different things with this in your homework tonight, but I do want to show you one last thing before we stop today. I'm going to show you the three rules that you may need when you're dealing with sigma. Okay, so the first one is this. So the sigma of k equals 1 to n of ak plus bk So if you have, the summation or the difference of things here, it doesn't really matter. But if you've got that, then this will end up giving you the same thing as if you were to separate it into pieces. So you can write k equals 1 to n of ak plus the summation from k equals 1 to n of bk. And you may say, well, what's the point of that? Well, you'll see in your homework tonight. There are times when it would be easier to separate it than it would be to do it all together. In fact, some of these up here at the top would probably have been easier to do if we, to make the summation. We wouldn't have to write out the whole thing if we use the idea of this being able to separate, because there's two other rules that I'm going to give you. Okay, the next one is, and this obviously works because as you're doing the summation of a1 plus b1 and then a2 plus b2 and then a3 plus b3, then all you have to do is use the associative property and commutative property of addition. You get to move them around and put them in whatever order you want, and then you can do the math. And so therefore that's why that works. Okay, you could write out that formula and you could kind of show that, prove that mathematically. The next thing we're going to do is we could go from k equals 1 all the way up to n of c a to the k. Now if we think about that, that would be c times a1 plus c times a2 plus c times a3 dot 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 all the way up to an, which if you factor the c out, then it's just c times a1 plus a2 plus a3. So essentially it's equal to c times sigma of k equals 1 to n of just ak. So if you have a constant, that constant can be pulled outside of the sigma. Again, you may say, okay, Mr. Bauer, this is pointless. Well, no, it's actually not. You'll use this later, especially when you get to realize that sigma is actually much more significant than just sigma. You'll see this again and it'll look a little bit different. Okay, the last rule is this one. And this one again we'll be able to kind of make sense of. We'll go from k equals 1 to n of just a constant. C always just stands for a constant whenever we deal with it. So we've got the sum from 1 to n of a constant, which means when k equals 1, I get c. And then when k equals 2, I get c. And then when k equals 3, I get c. And then when k equals 4 equals c, and you get the idea, all the way up to however many we have, all the way up to n. So again, this is if it's starting at 1 up to n. Then I've got 1, 2, 3, 4, all the way up to, well, I'm going to end up with how many c's? Well, I'm going to go from 1 to n, so I'm going to have n c's. And if I have n c's, then the answer is just c times n. And again, this idea will be important as you're trying to simplify things and try different things and make sigmas easier, as well as when we get into integrals and you realize that integrals are just big fancy sigmas. All right. Anyway, so that's for tonight. That's all for tonight, and hopefully this is enough to get you started on some nice mathematical problems. Ciao.